Oh, crap. Hold on a second. I misspelled the title. ETC. I hit backspace just whenever I went to hit enter, the backspace took. So it's ETC vice ET. That's okay. I can fix that afterwards.
All right, we're live.
Yeah. All right. Go ahead and take a few moments to adjust your screens and your audio as needed. And I'll see if I can get everything else adjusted. Okay. Now, if you're getting any audio feedback, you can cut down your YouTube audio. And it looks good on my end.
I just dropped the link in the Telegram group.
Okay. And now I'm going to go here. Gallery. Okay. Thanks for that, Philippe. I appreciate it.
No worries.
All right. And we're going to do the pop-out chat, right? Okay. So if you guys can hear me out there, feel free to put a note in the chat. I can see you there. Pop-out chat. There we go. Okay, looks like we're all set there. All right, Josh says he can hear us loud and clear. Thank you, Josh. Appreciate it. All right, now I'll get started shortly because I don't want too much lead time. I can't go back and clip the video. What I've done is I've clipped the videos before from the front, and it kills the chat feed on the replays. You can't watch the replay if I clip the video. All right. Thanks, everyone, for dialing in. I see there's a few people dialed in. So we'll go ahead and get started because the people will probably watch replays later on. What we're going to do today, we have Alex Tsankov here from Ethereum Classic, and he's going to be talking about the SHA3 algorithm and Astor testnet and other items that he has on the list. I have some notes here with it. And what I wanted to do is, before we get into the deep blood and guts of the SHA3 algorithm that Alex has built, is first, I want to talk about what Ethereum Classic is and proof of work very briefly here. So proof of work is a puzzle solving process where we have what you call miners out there. The miners are trying to solve a puzzle. The puzzle is extremely difficult to solve, but once the answer is found, the answer is easy to verify. And what the miners are doing is the more hashing power they have, the more processing power they apply to solving the puzzle, the more secure the network. And that's where the term proof of work comes from. And what these miners do, once they find a solution to the puzzle, they transmit it out. The other miners verify, yes, that is correct. So that miner gets to create what's called the block, which includes all the transactions that miner has collected, and that miner receives a reward. What that does is it prevents hostile miners who try to do what's called a 51% attack. They try to attack the network, and they try to inject invalid transactions or false transactions where they say, hey, that money went from that person to me, or from that person to that person, or whatever they tried to do. And they would try to inject a false transaction, but they can't because the good, honest miners are working harder and have more hashing power. And so that will lead us to some of the history. Now, Alex, if I got any of that wrong, feel free to correct me. I'm just trying to give that basic warm up.
I would say the best way to sort of add on top of that is that the network basically views the version of history, the ledger of transactions with the most proof of work behind it is considered the valid one. So when you were describing a 51% attack, what that basically means is I sent money from me to you, and then the network built a few blocks on top of that. So it got some work built on top of it. And then when I sent it to you, I started mining secretly another chain that never recorded that transaction. So I might have sent it to you. You gave me something. Let's say I bought a car. I sent it to you. And then let's say after a period of time, I actually released this secret chain that I was mining in the background, and I published that to the network. And if it has more work than the honest, legitimate chain, then all of the members of the network will then move to that other one, which never had the original transaction. So I get to keep the car, but you never actually had the money in your account because that was on the smaller chain. Yeah.
Yeah,
So
that's an
what a
excellent
51% attack
example.
is. It's a really bad thing to have happen. It's not a fun thing to have happen, but it's entirely into the ethos of what a decentralized network is. So when you don't have a central authority figure that says this is the right version of history, this is a wrong version of history, all that the members of the network have to go on is that which has the most hashing power associated with it.
Excellent. Wow, that's a much better description on the details of how the proof of work mining algorithm works. So what we have to cover today with Alex, I took some notes on, we had some emails going back and forth, and what Alex is going to touch on is, what is SHA3? Why is it a good replacement for Ethhash in the ETC community? So I'm assuming that the current method is Ethhash.
Yes.
A call to action. What are we doing right now? You're going to talk with us about the Astor testnet.
Yep.
And you're also going to tell us about plans for the future. And what we'll do, for those of you who are dialing into chat, feel free to leave us comments in the chat, but we'll take all questions at the end, because Alex will probably, he'll probably answer your questions during the course of his descriptions here. Philippe and I have talked with Alex before, and he is an outstanding speaker, and he explains things extremely well. So Alex,
you, Rick,
you're welcome. I am so glad that you came on Digital Fortress on this program. Whenever you answered, I was like, oh my God, I can't believe it. He answered. I love this guy. Okay.
Always happy to be on here.
Thank you so much. And so we'll go ahead and start that off with, well, we were leaving off with proof of work. What is the proof of work? And what Alex does is he writes the code to solve the puzzle.
Yes.
And that leads us to SHA3 and Alex. So Alex,
yes.
Tell us what you'd like to say about this.
So all right. So the first question that we need to actually talk about is, what is SHA3? So SHA3 is a hashing algorithm. Now, a hashing algorithm is probably the most important algorithm in all of cryptography. And what it does is very simple. You give it input. It can be any input. It can be it can be the length of a book. It can be a huge file. It can be just a sentence, whatever. It goes through this function, and then that function spits out a random set of characters that is completely different depending on what you put as input into the hashing function. So, for example, if I put in the string, the dog is a golden retriever, it'll spit out a bunch of random characters. And then if I put in the dog is a beagle, it should spit out an entirely different set of characters with no ability to be able to see any similarities. It needs to be completely random coming out of that. So that is the most important thing to understand about hashing, is that it goes one way. So you can put data in and you get this random data out. And as long as you put the same data into it, you should always get the same output out of it. And you should never be able to sort of figure out, based on the data that you get out, what you put in. So if I get out a random string of characters like 0xAZ5NXY, I should not be able to figure out that was this dog is a golden retriever. So does that kind of make sense?
Yes, much more so. Great example.
Yeah, so that's what a hashing algorithm does. Now, why is it so interesting? Well, it's interesting because we were talking earlier about proof of work. So proof of work is you're taking this huge ledger of transactions. So it's everybody around the world that's transferring money, Ether Classic, between each other, running computer programs on the blockchain, running smart contracts, etc. It's bundling that up. And then we're doing millions upon millions. Actually, at this point, it's like trillions of computer cycles a second to create a very, very special hash output that has a bunch of zeros in front of it. So it's just like the network says, hey, this is the ledger. Make sure you spit out a hash of that has 30 or 40 zeros in front of it. Now, actually, that's really difficult to do because it's a completely random process. So if I tell you, find me a hash that gives me 40 zeros in front of it, you are probably never going to be able to do that by hand, because you're going to have to go through so many different random guesses to get there that it's going to be impossible. So the process of mining is basically taking that ledger in and then doing as many of these cycles as you can that you can find this answer, and then you submit that to the network. So what SHA3 is it's currently, SHA3 stands for Secure Hashing Algorithm 3. And it was the product of about 10 years of competition that was put on by the National Institute of Science and Technology to basically create the most efficient hashing algorithm and safest hashing algorithm possible. Because one thing that a lot of people don't know, or they don't take into consideration, is that these hashing algorithms actually break over time. So the worst thing that can happen to a hashing algorithm is that I can find two strings that hash to the same thing. So for example, if I had the string XYZ123 and that equaled, hash 1, and then I put in another string that says ABC578 and that hashed to the same thing, that's a huge problem. That's called a hash collision. And that actually does happen with hashing algorithms. So some of the first hashing algorithms that were created in the 90s. I don't know if you've heard of MD5 was one of the first ones. And then what happened is it worked for a little bit, and then researchers and mathematicians actually found a collision there, and it broke. And what happened is that the government basically said that hashing algorithms are a matter of national security because they're used throughout cryptography, throughout computing. They're used everywhere. So the very first, U.S. government designated safe hashing algorithm was called SHA-1, Secure Hashing Algorithm 1. And it was actually created by the NSA in the 1990s for this purpose, to hash effectively. Now, around 2005, people started talking about potential attacks that could be done against SHA-1. So it was a little bit earlier than, probably around 2001. So the government basically said, all right, well, we have SHA-1. It works pretty well. There are these theoretical attacks. We're just going to make all of the inputs and the variables just bigger. So SHA-2 was created, and SHA-2 is basically the same as SHA-1, but it just uses way bigger numbers. And that gives a good degree of safety. So basically, SHA-1 started to have weaknesses discovered in the early 2000s, late 90s. The government basically designated SHA-2 to be Secure Hashing Algorithm 2, and that was the official recommendation. So if you're doing things like encryption, software development, et cetera, HIPAA compliant stuff, FIPS compliance, these are all sort of really big things. You needed to use SHA-2 because that was considered the gold standard in safety. There's another big user of SHA-2. So in 2000, I think it was around 3, when there started to be theoretical attacks posed against SHA-1, they designated SHA-2. And then in 2007, SHA-1 was officially broken. So Google basically released a big message saying, you know what, we ran our computers, we ran this many million compute hours, and we actually were able to create a collision on SHA-1. So SHA-1 was broken, and everyone moved to SHA-2. Now, if you pay attention to history, there was an important invention that came out in 2009, and that invention's Bitcoin. And Bitcoin used the best cryptography available to it at the time, which was SHA-2. But at the same time that Bitcoin was coming out, the government recognized that, hey, if SHA-1 is broken and SHA-2 uses the same basic construction of it, we potentially are going to have a failure with SHA-2 at some point in the future. So they put out a big call for a competition, basically saying we need to create a new hashing algorithm. And that hashing algorithm needs to be of a completely different fundamental construction than SHA-2. We can't just raise the variables again. That's not going to work. So over 60 different teams from all around the world applied to be a part of this competition. And the team that basically created SHA-3, they were called Team Ketchak. And I have a podcast actually with the creator of it. He was a fantastic mathematician, Dr. Guido Bertoni. He's based in Italy. And he came up with this idea for what he called the sponge construction, which was an entirely different mathematical fundamental way of producing hashing. So the competition began in around 2007. It didn't really become clear that Ketchak, which is what eventually went on to win the competition, would be as good until about 2010, when it came down to about 4 finalists. And in 2012, it became very clear that SHA3 was probably going to go to this team Ketchak, just because there were people all around the world testing it, and it seemed like SHA3 was actually really going to be the best. And then in 2014, it basically was, everyone kind of knew that SHA3 was going to win. And that was around the time when they started creating Ethereum. So the developers at Ethereum, and they made a fantastic decision. They're saying, let's use the most cutting edge cryptography available at the time, which was SHA3. So they use SHA3 everywhere throughout the code base. So when you're writing software programs on Ethereum, you're using SHA3 all the time. But they made a big mistake, which was, and slow me down here if you have any questions. I'm getting kind of deep into the history.
Feel free. Yeah, let us know in the chat if it's going too deep.
Yeah.
I think you're doing a great job, Alex. I'm following along.
Yeah.
Yes.
Okay.
Yes.
So
I'm enthralled.
Okay. So this is really interesting. So basically, in parallel to these developments in the cryptography world, see, this is the funny thing, is that actually people in cryptocurrency space don't really know that much about cryptography. Most people in the cryptography space are like mathematicians, the type of people that work in universities their whole life doing kind of theoretical stuff. So there really wasn't very many people in the cryptocurrency world paying attention to it. And what they did was they had this idea. So this was an idea that Vitalik, who was the creator of Ethereum, had, which was, okay, well, the thing with SHA-3 is that it's actually so efficient of an algorithm that it's very easy to build dedicated mining machines called ASICs for it. So ASICs are these single purpose units that just do one thing and one thing only, which is hashing. And, Vitalik had this idea that, well, ASICs aren't good because it means that somebody who's a professional miner, so running a whole data center of these mining rigs, can have a huge advantage over a, little person that can't necessarily afford to buy an ASIC. So what they did was they decided, instead of using SHA-3 as the mining algorithm, they were going to write their own, which was called Ethhash. And Ethhash was a hashing algorithm that, and I'm not making this up, it was designed to be slow. It was actually designed to be very, very low performance. SHA-3 was specifically selected by NIST because it was high performance and very safe. Ethhash was selected because it was very, very slow. And it never went through any of the trials or testing that SHA-3 went into. And in fact, if you look at the documentation for Ethhash, it's barely just one page on GitHub. It's scary, actually, how poorly documented it is.
I saw the charts you had posted on Twitter, and that was the first thing that got my attention. I can understand a pretty picture.
Yes.
I saw that. I was like, wow, there was a performance at a level 10 and something else was performing at level 4. And I'm like, is there really that much of a difference? Yeah, I guess so.
Oh, yeah. So the thing with hashing algorithms is that they're not all created equal. If you want to have a safe hashing function, a lot of people can write them, but there's a huge performance difference between them. So a lot of people entered this competition of 60 hashing algorithms, and SHA-3 Ketchak was selected because it was stupidly performant. We're talking about 4 times the efficiency of SHA-2 before it, which meant for 1 joule of electricity, you could produce 4x the amount of SHA-3 hashes than you could do SHA-2 hashes, and a bunch more than anything else. We're talking about 10x the other competitors.
That was the chart I was talking about. Keep those charts coming. You did a great job with that.
Oh, yeah, those charts were incredible. So basically what happened is that Ethereum Classic was formed in 2016 when sort of the network split apart. One group of people, the Ethereum Classic community, believed code is law, bailouts are wrong, whatever's running on this chain, we're not going to change. The Ethereum people had more kind of this more fluid idea, which is that, well, the chain is based on social consensus. And if the social consensus doesn't like what's going on, we can just change things around. So basically we ended in a situation where Ethereum Classic had about 1/20th the hash power that Ethereum did, and it was 51% attacked about in early January. So as a result of that, a lot of people in the community said, okay, well, we basically had this horrendous attack that was just done to us, and we need to figure out a solution. And what I said is that the best solution that we can have right now is to adopt the best algorithm possible. And that algorithm is SHA3. And the idea is that once we're using SHA3, we're going to be able to build our own mining community, and we're not going to be dependent on the Ethereum community, and we're not going to be dependent on this Ethhash algorithm, which has actually caused us a bunch of problems and that I actually don't believe is very safe. You know, if for example, if you were using Ethereum Classic to, let's say, I don't know, secure an airplane. I don't know why, but imagine you were trying to do a secure an airplane. It would be illegal to use a bad hashing algorithm there. It's not a matter of it's not a good idea. You would actually not be allowed to use an unsafe hashing algorithm in an airplane. So the question is, why are we using that in a basic blockchain system that's securing billions of dollars of wealth and potentially the future banking system of the world? So that was, so basically after that, I worked together with a few people. We created a proof of concept testnet, which is entirely SHA3 based. It's called Astor testnet. Anyone can join and mine on it. And basically we're proving the viability of SHA3 as a mining algorithm. We've mined about 100,000 blocks on it, and everything's going great. So that's kind of, I guess that's a condensation of everything that we mentioned in the email.
Yeah, that's awesome. You know, is there a reason why people would not use SHA3 because it's you can use an ASIC to mine using SHA3? So what's the drawbacks? Let's say we switch over to SHA3.
Yeah.
Switch Ethereum Classic over. What's the drawback to it?
So all right. So there's one concern, and I totally am sympathetic to this concern, which is that because SHA3 is so efficient, you can build an ASIC for it, and that's going to make it so that small people can't mine at home on their GPUs profitably. Keep that in mind. Anybody can mine SHA3. The question is, can you mine it profitably? If a bunch of big guys were to start mining SHA3, then it no longer is very profitable for people to be able to mine it at home. Now, here's the reason why I actually don't buy this logic, although I am sympathetic to it. First of all, this idea of ASIC resistance is false. So every time this has been tried before, there actually have been ASICs that are built for the algorithm. And what's worse is that those ASICs are then kept secret and people mine with them in secret. So it's actually very difficult for people at home to even get access to that stuff. The beauty of SHA3 is that it's a completely open and fair algorithm. The information for how to build ASICs and FPGAs are completely open online. So really anybody can participate with it, and it wouldn't be any different than Bitcoin mining. And then the second argument that I have against it is that it's just flat out unsafe. So let's say Ethhash is great, it's ASIC resistant and all that. If that algorithm were to fail, then it doesn't matter that it was ASIC resistant. The network is just broken. The math doesn't line up. And once that happens, basically we're just done. You know, there's no point in mining at all. All that energy that we spent in the past to secure this ledger is just worthless at that point. So if someone could show me a algorithm that is ASIC resistant and has been through the levels of trials that SHA3 has been through, I think that it's a worthwhile debate to discuss whether or not we should adopt that algorithm. But the fact is that nobody's come up with it. And there's a lot of people in the cryptography space that actually say that ASIC resistance is fundamentally pseudoscience. It's not possible to achieve it. And by doing it, you actually expose yourself to a lot of unsafe repercussions.
So you could always program an ASIC to do whatever the software is doing. I don't see why you couldn't. You could always do it.
And there's an economic incentive to do it too. So if you're economically incentivizing people to mine, of course they're going to come up with the most efficient miner possible. So you're never going to have sort of the security that you want.
Yeah. And, you know, I would do it from home. If you used that, I saw on Twitter about a year ago that somebody wanted to, there's a company in China and there was a company that tweeted something out saying we're making these miners that you can purchase and use in your home. Now, every time I've tried to look up how to purchase a miner, we did GPU mining. We did it on 0x Bitcoin.
Oh, sweet. 0x Bitcoin uses SHA3.
Yeah. But that was a year ago. Since then, the miner, that was a video card miner. And those video cards became very valuable by Christmas time. So off to eBay they went. And if I had an ASIC, I wouldn't do that. The ASIC would sit there crunching away, and I wouldn't sell it on, well, I could sell it on eBay, but it wouldn't become that ASIC won't become so valuable like the video cards did. You know, when you have those titanium 1070s and it's late November, those things fly through eBay like, oh man, it sold like, I don't know, like 12 of them in a matter of 2 weeks. Wow. If I had an ASIC though, that baby'd still be running in my garage, but yeah. That was an awesome explanation, Alex.
It was. Alex, I have a quick follow-up question.
Yes.
So we went through SHA-1, SHA-2, and now we're at SHA-3.
Yes.
And there's been probably a decade separating each of the SHAs, give or take a few years.
Yes.
So a decade from now, do you foresee that SHA-3 will become irrelevant? And if so, how will Ethereum Classic or the Astor network mitigate these threats of just SHA-3 just leaving, and then there's SHA-4 or whatever algorithm is available in the next decade?
So that's a really, really good question. So first of all, a lot of people are currently researching SHA-3. So it is considered the safest hashing algorithm around today. And people are performing all sorts of research specifically looking into quantum resistance. So will a quantum computer be able to crack SHA-3? And actually, SHA-3 has a bunch of fantastic quantum properties, which makes it very difficult for a quantum computer to break it, which is, again, part of the reason why I was given the SHA-3 designation. And then second of all, the fundamental construction of the algorithm is just so sound that if right now there's nobody that's really figured out a way to break it. That being said, if there ever was a case in which it appeared like SHA-3 was going to be broken, I will be the first one saying we need to move on to the next best algorithm that we can find. I do not like this idea of just, oh, we're never going to change. No, cryptography is science. Science moves forward. You know, we have to be using the best thing that we have access to. And right now, SHA-3 is the best technology that we have.
Yeah. Hey,
yeah.
Oh, I'm sorry, Alex. There was a good question in the chat. I know we're going to get to the questions at the end, but I think it fits here. Someone named OCG asked, Alex, how do you prevent the NiceHash attack vector, though? And is that my OCG? It says Old Crypto Geek.
Alex, oh, yeah, that's OCG. First of all,
how do you prevent the NiceHash attack vector, though?
Yeah, so you really can't. So, all right, just for some background, what NiceHash is this this company that does rentals. So basically, let's say I have a bunch of GPUs. I can say, I'm going to put my GPUs on the market on NiceHash. That means that anyone that can buy those GPUs can then point that to a bad mining pool, and then that mining pool can then attack a coin. And you, as the person that's selling to NiceHash, is never going to know that you were being used to attack that coin. So I think that's the question that he's asking. So here's the reason why I don't think that it'll be a problem with SHA-3 is because if we get to a stage with SHA-3 where the vast majority of people where Ethereum Classic is the dominant SHA-3 algorithm. So that means most people that are mining SHA-3 are only mining Ethereum Classic. They are tied to Ethereum Classic. Keep in mind that is very different than the current state of Ethhash, where ETC and Ethereum share the same hashing algorithm. So there are 20 times as much miners that care about Ethereum than care about Ethereum Classic. So if we reach that stage where Ethereum Classic controls the vast majority of miners on that algorithm, then I think that the miners are not going to be incentivized to want to sell their hash power on NiceHash because they have a stake in the network and they don't want their FPGAs or their SHA-3 ASICs to become worthless. So I think that that's the reason why.
So that's, you could learn by doing it. Is that what the Astor network is doing?
Yeah. So the Astor network is, it's totally open for people to mine on. It's you can actually go to astor.host and that's where it's on. And just a little background, all these test nets are named after subway stops. So I'm based in New York and I took the Astor place subway stop every morning for about a year and a half. So to me, it was a big honor to be able to actually name one of these test nets after the subway stop that, you know, I was taking every morning.
That's brilliant.
Yeah, no, I love it.
Oh, wow. All right. Let's see what we got here. We covered the Ethhash, got the questions answered, SHA3. You have a call to action.
Mm-hmm.
And the call to action is because the Ethereum Classic community, we were talking about this right before we went live. They're so decentralized that the people, like, you don't work for Ethereum Classic Corporation, right?
There is no company or foundation or anything.
Yeah. So if you want to switch, you got to do a call for action, and other people out there have to agree and say, yeah, I think Alex is right. Let's try switching over to SHA3.
Yep.
That's pretty much how it works.
Yeah. So it'll be a very interesting question I mean, I don't even know the answer myself as to how to get everybody to agree on this. All I'm doing is I'm putting out the best reasoning that I have. I have put out a technical implementation, which is Astor testnet. The code for that is open. I have written a block explorer, which allows you to explore Astor testnet. I've written a CPU miner, which can allow you to mine with SHA3. I know about some people that are working on FPGA, open hardware implementations of SHA3. So at this stage, it's a matter of the community getting together and agreeing on a date, saying this is the date in which we will switch over. And I think that once we have that date, then we're going to be able to align everything, and we're going to be able to get the software implementation and the miners ready for that date. And what I'm shooting for is mid-2020 at some time. If we can get SHA3 turned on mid-2020, I think that's going to be a great boon for the network.
Sounds like herding cats.
You have no idea, Rick. I mean, this community is so distributed and spread out over the world. Most people don't even speak English that are in the ETC space. That's why I'm doing all the things with the charts, because it's like, you know, if I can't talk to them about it, maybe I can show pictures.
Yeah, the pictures. Oh, that's why your pictures are so good. Yeah, I know what you mean, man. I'm so simple. I got kicked out of all the Ethereum Classic chats, or I got muted. I can't even get back in. I'm like, oh well, what? I don't care. I'm just gonna keep buying it anyway. I don't care.
Wait, let me know. Actually, which ones have you been kicked out on?
I'm muted on ETC chat, the little one.
Discord or on Telegram?
On Telegram.
So the guy that runs that is a complete asshole. Seriously, I hope that people reach out to him. He is like censoring people. He's preventing people from speaking. I don't know. You know, the Saturn guys, they're running the biggest DApp on Ethereum Classic right now.
Oh, yeah.
They were banned from the ETC Telegram. So whoever that is, seriously, just stop. Seriously, stop. This community is not about censorship. It's about as many ideas as possible.
Yeah, I think I posted something positive, and they're like, get the hell out of here. You can swear on Digital Fortress. Over on Philippe and I's other podcast.
Well, seriously,
we can't say swear over there. You can say shit all you want. You say asshole.
Yeah. No, seriously, censorship, that is the one thing I cannot deal with, especially in crypto. It's like the whole point of this space is that you can speak your mind and come up with new ideas. And when you start saying that those ideas, you don't agree with them, so I'm going to kick you out of the official chat room. Seriously, go to hell. Like, yeah.
Yeah, we digress. But yeah. You're right. You're right. We digress, but it needed to be said.
Yes.
It needed to be said. All right. So we got Astor testnet. We covered that.
Alex, I wanted to ask a quick question. You don't mind, Rick?
Oh, go for it. The only thing we got left is plans for the future, at least what was on the list.
We hit those. I want to start getting to the other questions on YouTube soon, too.
Cool. So if anyone has questions, throw them in on YouTube. Philippe, you got it, sir.
Okay. So what you were explaining before, it seems like Ethereum is a ticking time bomb. Mm-hmm. And, you know, eventually there may be a hash collision within Ethereum because of they didn't stick to certain processes writing their code. It seems like they have one page on GitHub. Explaining Ethhash. So what is the doomsday scenario? What if, you know, I don't know, there's a massive bull run within the next 6 months and everyone's buying up Ethereum and there's a hash collision and a lot of people just end up hurting. Do you think that sets back the crypto community? How imperative is it for ETC to get the ball rolling and get this out as soon as possible?
Well, so here's the thing, is that the Ethereum community doesn't even want to pay attention to this issue because they believe they're going to be moving to proof of stake within the next year. So my thing to them is like, look, you guys chose Ethhash because you wanted to do this economic planning experiment. You didn't want to pay attention to the real math and the science that people have been doing. You wanted to do economic planning, which is what Ethhash is. If you want to continue that experiment into proof of stake and just abandon Ethhash, fantastic. Be my guest. I want the Ethereum project to succeed. I like a lot of people associated with it. But at the end of the day, I'm focusing on Ethereum Classic, which is going to stay proof of work for the foreseeable future. I'm talking about multi-decades long. So if we're going to be building this long-term proof of work system, we have to use the best hashing algorithm that we currently know of. But yes, I mean, absolutely, people can lose a lot of money and dApps can be ruined if there is a collision with Ethhash. And that it's not that out of the realm of possibility.
Oh, so now I totally get the point. If you're running Ethhash and one of those collisions you were explaining at the very beginning occurs, what happens? That could be catastrophic.
Oh, it's just, we all go home. It's just done.
The blockchain's over. It's no longer a chain. It's like a block smash or something.
Yeah, no, I mean, it's like you can think of some theoretical attacks where like one, government agency is able to produce every block in the future. And then they can choose to censor people. They can choose to take all the rewards for themselves. They can make the network grind to a halt. There's all sorts of attacks that you can do once you find a collision.
Oh, wow.
That's terrifying. Someone might be sitting on the kill switch right now, like just waiting for the perfect time.
Yep. And we wouldn't know about it. Yeah.
Yeah. They're just saying, look, I found where collision occurs and I'm just going to wait on it. And once I see the right time, bam. Good point, Philippe. Yeah, man.
Yeah, no, that's fantastic.
Yeah. Any other questions in the chat? Uncle Chop Chop says Ikesho Traf. Yeah. Uncle Chop Chop. There you go, buddy.
Uncle Chop Chop.
It would be catastrophic in nature. Oh, but we don't know. I guess you could simulate it if maybe someone has simulated it. So SHA3, the pros and the cons. The pros in summary there are it's proven, more secure, no known collisions. It's vetted. It's been run on 0x Bitcoin.
Yes. Big fan of that community, by the way. That was like that's one of my favorite open source communities out there. Infernal Toast. I don't know if you know him.
No, I don't. I didn't. My partners in mining were the ones taking care of that. And
he's a fantastic dev. He's based in Detroit, actually, and he just basically came out of nowhere and just built this community out of scratch with using really, really sound economic principles.
Yeah, it was brilliant. In case anyone doesn't know, 0x Bitcoin is a mineable ERC20 token using the SHA3 algorithm that Alex is talking about with us here today. And I saw you reference it one time and say, 0x Bitcoin been using SHA3 for a while. I guess if at least you have a test bed, at least you have a reference you can point to and say, they've been doing it. It's working for them.
Yes.
And
they would benefit a lot from Ethereum Classic moving to SHA3 because now they have all these miners that like SHA3 and they're like, okay, well, we can mine ETC. We can do merge mining potentially with 0x Bitcoin. So there's a variety of things that you can do.
Yeah. Hey, there's another question over in chat. Is Old Crypto Greek asks, why Ethereum Classic for finance, Alex?
Oh, well, I mean, so the short of it is that you have to ask yourself, why are people using blockchain at all? They're using it to minimize trust. Okay, it's way more economically efficient to use a blockchain than having to rely on these big financial institutions that we've had in the past to do our financial transactions. So the reason why ETC and Ethereum Classic is so important is that let's look back as to what is in the Genesis block of Bitcoin. There's a very important quote, which everybody needs to know, that in the first block of Bitcoin is encoded in there, Chancellor on the brink of second bailout for banks. Okay. And if you believe that the core use case of blockchains and cryptocurrency is to fix the problems of the banking system, of the financial system, then Ethereum Classic stands for what we believe in. Ethereum bailed out the DAO when it failed. It basically it reversed the code, and it gave the money back to those investors who, you know what, they made a bad investment decision and they should have lost their money. And the beauty of ETC is that it obeyed the principles of code is law. So I feel very strongly on that.
Yes. You know, when I read about that, that's what really hooked me on Ethereum Classic a little while back. It wasn't, okay, Ethereum Classic and Ethereum, same technology, right? Same Genesis block. But it's, if you read the Ethereum Classic, it's like the Constitution or something like that.
The Declaration of Independence.
There you go. It was the Declaration of Independence for Ethereum Classic. And when I read it, I was like, wow, these guys totally get it. And I didn't even understand it to that level of detail. It was so well written. So if you get a chance, read the Ethereum Classic Declaration of Independence. I think there's some stuff to be learned by Cardano about Ethereum Classic by looking at how Ethereum Classic does things and how Ethereum does things. Ethereum does things well. I do got to give a shout out. I think Ethereum and Ethereum Classic are the two most decentralized cryptocurrencies out there. I mean, they're operating completely decentralized. Just with Ethereum, it's a little bit culturally centralized, which is okay.
Absolutely.
You know, it's okay. And with Ethereum Classic, it's very technical, political, and culturally completely decentralized to the point where it's like wild, wild west, which is kind of cool.
Oh, and I think it's great that you brought up Cardano, because I actually see huge synergies potentially between Cardano and Ethereum Classic. So specifically that if ETC were to adopt SHA3, you now have, think of it almost like an engine, pretty much. It's a proof of work engine. That Cardano is its proof of stake. So if it needs proof of work to, let's say, compute something, or it needs that hash power for some reason, it can easily plug right into ETC, and it can leverage that hash power to be able to secure, let's say, a financial instrument. It can use it as for a game. I mean, I don't know the use cases yet, but I think that these sort of cross-chain compatibility between Cardano and ETC is going to be huge in the future.
I think so too. If you look on daedaluswallet.io, that it still has two icons there, one for the Cardano side, and the Ethereum icon is there for either Ethereum or Ethereum Classic proof of work. So the concept is still brewing in the background, and the work's all being done. The NiceHash research papers have been written. I don't know how much code has been written. I'm not involved in that process. But yeah, I think there's a huge collaboration coming over the coming years. And I'm always looking in the years out. I'm not worried about, did the chart go red or green today? Well, okay, it doesn't matter. Okay.
Yes.
I'm in it for the money. I'm telling you, I'm in it for the money, fully, completely, 100%. I wouldn't be doing it if it was, but long term, not today, tomorrow, up or down. I'm talking big picture. So there's a few people came up in chat. I saw Pex showed up. Shout out to Pex, and also of note, there's a token out there, Bitcoin Classic token. It's a mineable ERC-223, which is similar to 0x Bitcoin, which was the mineable ERC-20. Are you familiar with the Bitcoin Classic token?
I actually, total confession, I wrote a lot of the code for Bitcoin Classic token. I mean, look, Bitcoin Classic token I like. I'll be real here. I think that they did not do a good job in reaching out to the OX Bitcoin community, giving that community the respect that it deserved for being first. And you know what? Bitcoin Classic token's great. I own some. I've mined a little bit of it. But for me to really become a supporter of it, I want to see them, reach out and make better inroads with the OX Bitcoin community, who was first and who came up with the idea. So either if there's some way to institute merge mining or some way that, 0x Bitcoin holders can actually get some Bitcoin Classic token, I think that's very important.
Yeah, that'd be neat to see some collaboration between the miners of the tokens. That's kind of cool. Yeah. So, Alex, I think we're about wrapping up here, or at least we're approaching that time. If you got anything else you want to throw in there, I just want to say I was really glad for you to come on to Digital Fortress here with us. And Philippe, thank you also for jumping in there at the last minute. I kind of toss it in. You always have great questions.
Oh yeah, I mean, seriously, Philippe, those are great. So just to kind of wrap up, actually, I'm going to be speaking in Vancouver on October 4th for the ETC World Summit. I'm going to be talking about SHA3. It's probably going to be a huge, it's a really important event because it's such a decentralized community. So this is going to be a chance to meet everyone in person and explain to them SHA3. And I would love to see you guys there. I mean, it's free to attend.
It's free to attend.
Vancouver, what are the dates?
October 3rd to the 5th, I believe. Or October 4th and 5th.
October 4th to the 5th.
It's going to be right in the middle of Vancouver. The hotel has a fantastic group rate. So like I was talking with some friends who said that if you were staying in the same hotel, you'd be paying double without the place. It's right in the middle of downtown Vancouver.
Are you going to be broadcasting from there?
I'm going to be speaking. So if you guys want to show up, man, I'd love to see you guys in person.
I'll try to make it. That's what I was wondering if you're going to be broadcasting. Can I watch it live on YouTube?
Yeah, no, I'm going to try to make sure it's going to be recorded. Whether it's going to be live streamed, actually, we have to figure that out.
Okay. And Alex, I appreciate the history that you went through there and a little bit about the history. And right before we went live, Alex got into some more history as well there too.
I love history.
Yeah,
that was awesome.
Well.
That was awesome.
Thank you, guys.
Right on. And so we're finishing up here over at Digital Fortress with Alex Tsankov, and he talked about the Ethereum Classic. He's an Ethereum Classic developer, and he talked about the Astor testnet and the SHA3 mining algorithm. Alex, one last thing. What needs to happen next? Is it we just need to get word out there until the Ethereum Classic community, they say, all right, let's evaluate this and say, should we stick with Ethhash or should we move forward? And I'll give you the last words here and we'll wrap up. What needs to happen?
So 2 things. First of all, go to astor.host, run a node, because you can start running a node, start mining, test it out, play with it, hack it if you can, break it, I don't know, improve it, whatever. I don't think you can hack it. It's pretty solid, so you can give it a shot though. Second thing, SHA3 mid-2020. That's the date we're going for. All right. So when people ask, when are we doing SHA3? It's going to be in 2020.
Excellent. I will put a link to astor.host down in the description after we're done here. And thanks for the information on Vancouver and everything else. All right, guys. Philippe, it's a great episode. I don't mind if we rip it and upload it on the Philpa channel. I think that'd be great.
Okay.
Because I want to share it. You know, we need to share this with the 5,000, 6,000 people on the Philpa channel.
Okay. Yeah, for sure. This was awesome. This was awesome.
Thanks so much, guys.
Thank you, Alex.
Alex, it was a pleasure.
All right. Great questions. See you
Take
guys.
care. Bye-bye.
All right. Bye.
And I hit end.